Hi students, all of you welcome. Welcome to Sunil Engineering Academy. I am Sunil Kumar Bandaru. Students, in this general science physics, we have completed electricity topic, magnets and magnetism, work power energy. Now we are discussing force and motion. So in the force and motion also one session completed. And these sessions are useful for all your competitive examinations. So in the motion, we have completed the differences between distance, displacement, speed, velocity in all the cases, uniform acceleration, and jerk. Okay, so now we are going to discuss equations of the motion. Very important, and angle of projections. Okay, so this is also very important session. And so many students are not sharing to your friends. Please try to share, okay, then only we can reach to more number of students and I can get the more interest to take more sessions, okay. And if anyone not subscribe this channel, please click on subscribe option, okay. So then you will get the notifications, okay. So after the acceleration and jerk, now we are going to the topic equation of motion. Equations of motion. Okay, we have three equations. Those are very important. These equations of motion generally we will take under uniform acceleration, motion of uniform accelerated body in straight line, not angle of projected. Okay, so coming to the equations of motion, the first equation of motion, before going to take the first and second and third equations, we have to take the terminology. In that equation, if we use u is said to be a initial velocity, that is starting velocity. Okay, velocity in meter per second. That means initial velocity means at time t is equal to 0. Okay, and v is nothing but final velocity. Okay, final velocity, that means velocity after certain time, after t seconds, if they have given like after t seconds. Now here if it is a is a uniform acceleration, meter per second square, uniform acceleration, that is meter per second square, time t is equal to seconds. In this case, the first equation of motion, v is equal to u plus at, and the second equation, displacement s. Here let us take here s is the displacement or distance. Okay, in case of a straight line, generally displacement and distance are equal, that is in meters. S is equal to ut plus half at square. Third equation, v square minus u square is equal to 2as. These three are very important. Okay, generally these are called as equations of motion. So note down these three. Note down these three. Okay, here we have to take some important points, guys. Some important points we have to consider. If we throw any body, we throw a body or ball upwards. Okay, if we throw a ball upwards, that is like this. Okay, so that is perpendicular like this. Okay, so if you throw a ball upwards, in this case In this case, the ball is going to reach a certain height. That height is nothing but maximum height. That height is said to be a maximum height. If a body throw vertically upwards with u velocity, upwards with u is the initial velocity. After certain time, it takes maximum height. Okay, if we throw a ball upwards with u velocity, after certain time, it takes maximum height. After that, it again reaches to bottom. Correct? Reaches to bottom. Here, T1 is said to be time of ascent. This is the terminology used in the physics. Time of ascent. Time of ascent means time to reach maximum height. Okay, that means if you throw any ball to the upwards, it takes the time to reach the maximum height is nothing but time of ascent. And T2 is the time of descent. What is means by time of descent? It is time from maximum height to bottom. Time from maximum height to bottom. Okay, and here if you throw a ball with the u is the initial velocity, whenever it reach maximum height, then what about the velocity, guys? Whenever it reaches to the maximum height, its final velocity is going to be stopped now. So if there is no velocity, that is only you can say maximum height. Correct? So that means whenever it reaches maximum height, then at maximum height final velocity is 0. Final velocity v is equal to 0. So you can take here a very important point. At maximum height, final velocity is equal to 0. That means kinetic energy is equal to 0. As velocity is 0, kinetic energy is 0. Okay, and in upward direction, acceleration a is taking as minus g. Why? Because here acceleration is opposite to gravity. Now gravity is generally in the bottom direction. Gravity is nothing but force of attraction. Okay, so in upward direction generally a is taking as minus g. In downward direction a is equal to consider as plus g. Okay, so now we have total time t1 and t2. So let us take a total time. Total time is equal to t1 plus t2, that is equal to 2 into t1 or 2 into t2. Why? Because always time of ascent is equal to time of descent. Okay, whenever there is no medium, that is no air, if we have the air, due to the air we are getting some differences. Okay, but if there is no medium, then we can say t1 is equal to t2. So whenever the t1 is equal to t2, the total time is equal to 2t1 or 2t2. So that means total time t is equal to 2 times into time of ascent. Time of ascent. That means time to reach the maximum height. Time to reach maximum height, or 2 into time from maximum height to bottom. Okay, maximum height to bottom. Very important question. The total time is equal to 2 times of the time to reach the maximum height, or 2 times the time from maximum height to bottom. Okay, so generally this time of ascent t1 is equal to initial velocity by acceleration due to gravity. In the same way, t2 also u by g. U by g. So then in this case, the total time is equal to 2 into u by z. Total time is equal to 2u by z. In the upward direction, total time t is equal to 2u by g. Okay. Now coming to maximum height. Maximum. So if you throw any ball upward direction with u initial velocity, whenever it reaches to the maximum height, at maximum height v is equal to 0 now. Final velocity is 0. It may not have more velocity at maximum height. If you are throwing upwards, then a is equal to minus 3. In this case, let us take a equation, third equation of motion. V square minus u square is equal to 2as. Okay, so whatever the height, that height only it is traveling, correct? The ball is traveling, whatever the maximum height, that is only traveling. So h is equal to s. So in this case, v square minus u square is equal to 2ah. If you want maximum height, v is equal to 0, u square 2 into a is equal to minus g, then h will becomes maximum. Okay, h will becomes maximum whenever v is equal to 0. V is equal to 0, h will becomes maximum. So in this case, minus minus is cancelled out, then h max is equal to u square by 2g. Very important, maximum height formula. H max is equal to u square by 2g. Okay, u square by 2z. In the same way, if you take any ball is accelerating downwards. Next case, case 2. If a ball is freely falling, let us take a freely falling. Whenever any ball is freely falling, then what is the initial velocity? You are not applying any velocity now, so just that is freely falling, so initial velocity is 0. Okay, or in case if any body starts from rest, any body starts from rest, in this case also take initial velocity u as 0. Very important this case also. Okay, in this case also u tends to 0 only. If a ball is freely falling, in case of accelerating downwards, same gravity side, so a is equal to plus g. So in this case, a is equal to plus g. Okay, a is equal to plus g. And that means if a ball is brought to bottom, okay, brought to rest. So now, if ball is brought to be rest, in this case, the ball is brought to be rest, that means just it is coming and it is going to be rest, means then what is the final velocity? Then final velocity v is equal to 0. Why? Because Whenever it reaches to the bottom, after that it is not at all moving. Okay, so ball or object. Okay, here ball or any object. So final velocity is equal to 0. Okay, so note down all these points. Noted. Now the acceleration due to gravity G. One term very important, acceleration due to gravity, denoted with the letter G. Okay, denoted with the letter small g. Here, what is meant by gravity? Just now I said gravity means force of attraction. Our earth having gravity means it attracts all the particles, correct? Force of attraction is nothing but can say gravity. Okay, and this gravity, acceleration due to gravity is not uh, same for different places. That means whenever the places are changes, this acceleration due to gravity may be changes. Okay, so acceleration due to gravity G depends on place. Okay, it changes from place to place. Okay, generally, if you can consider our Earth, here we are the poles, north and south. At the poles, it is the maximum. Okay, G is the maximum. And at equators, G is minimum. Okay, G is maximum at poles, and minimum at equators. Okay, minimum at equators. G depends upon place, changes from place to place. And if you can consider G is at Earth, in case of on moon, G is equal to G on Earth by 6. That means on the moon, the acceleration due to gravity is less. Okay, so it just changes from place to place. But if the mass changes, it may not change. G, very important point, note down. G does not depends on mass. Okay, for example, if A is 5 kg, B is 10 kg, then there G1 is to G2 is equal to not 5 is to 10, that is 1 is to 1 only. So due to A having acceleration due to gravity G1, if it is a G2, in this case G1 is equal to G2 only. Why? Because it does not depend upon the mass. One is 1 kg, one is 1000 kg also, it has same acceleration due to gravity. But whenever the place changes, acceleration due to gravity will be changes. Okay, note down this point is very important. Maximum at poles, minimum at equators, and does not depend upon the mass. Point also important. And coming to the G value, just wait. Okay, so coming to the g value generally g value is equal to 9.8 meter per second. Sometimes if they have given 10, so we have to take the 10. So approximately 10 meter per. Okay, so in so many numericals they will give 10, so then calculations will be very easy. Okay, so g is nothing but acceleration due to gravity, nothing but force of attraction. Okay, and let us take the three equations of motion due to this gravity, acceleration due to gravity. So the equation of motion under gravity, that is a is equal to g. In this case, the first one, v is equal to final velocity, v is equal to u plus at. It will becomes v is equal to u plus gt. Okay, second one, what is the second equation? S is equal to ut plus half at square. Here s is nothing but, let us take a height generally, ut plus half gt square. Third one, v square minus u square is equal to 2as. Here v square minus u square is equal to 2gs plus h. Okay, so these are three equations. If your body is freely falling, if body freely falls, then in this case, what is the initial velocity? Initial velocity is equal to 0. So then what will be the equations? V is equal to 0 plus gt and h is equal to u is 0 half gt square. Then v square minus 0 is equal to 2gh. That means v square is equal to 2gh. In case of some numericals, these formulas may be used. Okay, these formulas may be used. Note on these formulas also. Now coming to the equations in case of angle of projection. Okay, so let us take a projectile motion. Projectile motion. If you throw any object vertically with an angle of theta, it always takes the curved path. We can observe this one. If you throw any ball like this, it always takes a curved path. And here it will take the maximum height at a certain point. That is nothing but, can say, maximum height. This horizontal distance from initial to final is nothing but range. The horizontal distance is called as range. The total time is nothing but t. Okay, so take down some points. If a body throw if a body throw with an angle theta, generally theta is not equal to 90. Okay, so if a body throw with an angle theta like this, generally let us take a theta and is less than 90. Okay, so then it takes curved path. It always takes curved path. This motion is called as projectile motion. Projectile are also called as trajectory motion. Trajectory motion. Okay, so here it is nothing but u is the initial velocity. U is initial velocity. Okay, initial velocity. H max is the maximum height. Range. R is horizontal distance covered by body. Horizontal distance covered by body. T is the total time taken by the body. Time taken. Okay, in this case, here note down the formulas. These formulas are very important. Horizontal range R is equal to U square by G sine 2 theta. Here I am not deriving the formulas. No need of the derivation. Just waste of the time. So general try to remember U square by G sine 2 theta. Okay. And generally range is maximum at theta is equal to 45 degrees. Okay. And H max U square by 2G sine square theta. U square by 2G sine square theta. And total flight time T is equal to 2U by Z sine theta. 2U by G sine theta. Okay. So note down all these three formulas. R is equal to U square by G sine 2 theta. H max is equal to U square by 2G sine square theta. And T is equal to 2U by G sine theta. We have so many examples of this projectile motion. For example, that is jumping animals. Jumping animals. Jumping animals is like a projectile motion. If the kangaroo is jumping like this, rabbit is jumping like this. Okay. 6 hit by bat. Generally, that is also it is in like a projectile motion. Okay, object thrown from window. Thrown from window. All these are generally examples of projectile motion. Okay. For example, if theta is equal to 90 degrees, then what is the H max? U square by 2Z sine square theta. If you substitute theta is equal to 90 degrees, then H max is equal to U square by 2G. So we got the same formula. So that means if a body vertically throw upwards, vertically throw upwards. In this case, H max is equal to U square by 2G. Then what is the total time? 2U by Z. And what is the range? R is equal to U square by G sine 2 theta. U square by G sine 2 theta. Sine 2 theta. 2 into 90 degrees. Sine 180. What is the sine 180 degrees? 0. So horizontal range is equal to 0 in case of vertically upwards. Okay, so they may ask the question in horizontal, what is the range in case of vertically throw upwards? The range is generally 0. Okay, so these are the very important formulas in this projectile motion. All these three formulas are very important. Okay, so equations of motion, acceleration due to gravity, changes from place to place. Okay, at the moon it is g by 6. Maximum height formula. Okay. Okay, students, in the next session, we will discuss Newton's law of motion. Okay, Newton's law of gravitation, that equation. Okay, and the pending topics. Okay, okay, students, thank you so much for watching. And please try to share and give your feedback as the comments. And don't forget to click on like option. Okay, and also try to join in the Telegram link I have given in the description box. And some of the students are messaging that, sir, we are totally depending on you, like that. I want to say one thing. Please don't depend on any one person particularly. Okay, so you have to depend on you only. You are the main. Okay, so you are going to write the exam. So don't depend on any one particular person. So try to depend on you. Try to believe yourself. Okay, so try to make that is self motivated. Okay, so whenever you are in the demotivation, so try to close your eyes and think about if you got the job, how will be your life. Okay, then you can easily buy bike, even car. Okay, and you can get married, beautiful girl will come. Huh? No need to flirt a girl, no need to give line to girl. Okay, beautiful line girl, father will give you. Correct or not? Okay, so you have the money, whatever you want, you can do that one. So think like that. Okay, then automatically you will get a motivation. Your relatives, your parents, all will give you respect to you. Okay, all will be say, I'm proud of you, guy. Like that. So try to motivate it like that is self motivation is very important. Okay, so don't depend on any one particular person. If you want to get the job, so hardly try for that, then you will surely get it. Okay, so if you are not getting the source here, then you can try to search. Whenever there is whenever you search, then you will finally you will get one excellent source. Okay, correct or not? Huh? Okay, students, thank you so much for watching. Bye.